Welcome to classwork 6.4, section 4.7. There's a lot of content in this particular section, so feel free to pause it whenever you need to. Today we're going to cover all of inverse functions for trigonometry. So first is right here, sine inverse x. So first, I just have my xy axis ready. This is going to be like your new parent graph, in case you didn't cover this in trigonometry. This is a sine inverse graph. It's basically constructed from a part of the sine wave, and there's only three main points. 1 pi over 2, the origin, and -1, -pi over 2. So notice these are dots. There are no arrows here. Like that is the whole graph for sine inverse x. So you're going to want to really make a note here, like really box this thing. This is something you're going to want to memorize. This is like a parent graph. Like if I ask you what is sine inverse x, you should be able to graph this from memory. The domain, as we can see, is -1 to 1. The range is -pi over 2 to pi over 2. Okay, so that's our basic graph. Now, if I ask you to transform the graph on the right here, you should have no problem. This 2 means take the y values times it by 2, and this 1/2 will do the reciprocal operation, so x times 2 over 1, which is x times 2. So let's just play with the scale here. This is going to become pi and -pi on the y-axis, and the x-axis is -2 and 2. Now put your exact same 3 points there, and there you go. There's your graph, done. Now in terms of finding some values now, it says find the exact value of sine inverse of √2 over 2. So recall, on our speed quizzes I give you like sine of pi over 4, and you give me a value, right? That's √2 over 2. So think about it this way. Sine of some angle is going to yield some length. To be technical, it's a ratio of lengths, but for now, let's just call it a length. So the inverse function will do the reverse of that. It's going to take the length or the ratio, and it wants to give you back an angle. So for all of these, your answer should be some type of angle. Now, if we're looking at this thing, sine inverse of √2 over 2, the issue is that √2 over 2 happens in two places on the circle, right? If you imagine your circle. √2 over 2 happens both in quadrant 1 and quadrant 2. So to fix that, this is what we're going to do. I'm going to get rid of this. You simply just draw quadrants 1 and 4 like that, because that will cover every possible value for sine. That's all the y values. And then mark where √2 over 2 would be. That's right there in quadrant 1. And that angle is pi over 4. So there's your answer. So in our notes, I'm going to send it back up here. For the range, see how we have -pi over 2 to pi over 2 right above that? Just write sine right there. So that's a visual representation of quadrants 1 and 4. So for the next example, same thing. You highlight 1 and 4. That's for sine. So the range of the inverse function would be. I'm going to put a tick mark where -1/2 would be. And the answer is now -30. Now, a lot of people want to write 330, but that is not correct. Now, the reason for that is because 330, you'd have to travel outside the range, which you can't travel outside the range of the function. The only way you do that is by traveling from 0 straight down to there, which again would be -30. So make sure you always stay within the range. Next one. For cosine, very similar here. Actually, I should fix this. We don't want a t, or we don't want an x like that. We want a t. So have a t like that. We're going to put -1 to 1. There's 0, pi over 2. So same thing. It's constructed by simply taking a piece of the cosine wave, and then you just flip over the y equals x line. But for you guys, you're going to want to memorize this as like a parent graph. Okay, so again, you're going to want to box that. Memorize. These are your new parent graphs in trigonometry. You need to have these down. The domain we can see here is -1 to 1. The range, 0 to pi. So if I want to do some transformations here, I'm going to change right here. We can see y times 1/2. That is x times 1/2. So let's shrink the y values. This is pi over 2, pi over 4. And let's shrink the x values. That's -1/2, positive 1/2. And then let's redraw the graph. There we go. So there's our cosine inverse wave with the transformations applied. Now for finding the values, very similar to sine, we're going to highlight two quadrants. For cosine, as you can see at the range right here, 0 to pi is right there. So we can think of cosine like 1 and 2. So highlight quadrants 1 and 2. You're going to mark where -√3/2 would happen. That is right here. And that'd be 150 degrees or 5 pi over 6. I'll just circle 5 pi over 6. Both are fine. So for the next one, cosine inverse of -1/2. Let's put our circle. -1/2 is right there. That angle would be 2 pi over 3. Done. Tangent. So the tangent graph is probably the most interesting one. There are actually two horizontal asymptotes, pi over 2 and -pi over 2. And that's because from the inverse, you just reflect it over the y equals x. So the vertical asymptotes of the original become the horizontals. We're going to put -1 to 1. Then this is simply the halfway point, pi over 4, -pi over 4. And this graph is pretty cool. It looks like a cubic or a cube root graph. It's basically a tan graph on its side. And there's our tan inverse graph. The domain is going to be all real numbers, as we can see. And the range is -pi over 2 to pi over 2, but it's non-inclusive since we have those horizontal asymptotes there. And since the range is same as sine pretty much, tan is also quadrants 1 and 4, like that. So you're going to highlight quadrants 1 and 4. Think about √3. That's in quadrant 1 at the top. That is 60 degrees or pi over 3. Either one of these answers, perfectly fine. Okay, so that's part 1. Now part 2, hopefully you're pretty comfortable on that, is we're going to put everything together. To summarize, let's put a big picture right here. This is going to be the range of inverse functions. If you took my class last year, hopefully you remember this picture. We're going to write sine like that. Look at this, cosine fits so nice, and then we're going to put tan right there to make this cost across the x-axis. That's a really easy way to remember the range of the inverses. Now we're going to do a bunch of compositions of these. So now we see the functions within the function. So the first thing I want you guys to do is to classify these. There are two types of questions we're going to do. Letter A is an example of a triangle question, meaning the inverse is on the inside, sorry. Letter B's are the inverse on the outside. We're going to call those circle questions. Okay, so let's quickly classify these. So triangle, circle, inverse is on the inside here, so we're going to call this a triangle question. Inverse is on the outside, so that's a circle. Inverse outside here, so we'll call this circle. Let's first start with the triangle questions, because those are pretty easy. It says cosine inverse of 0.6. Let's first make that a nice fraction. Cosine inverse of 3/5. What you want to do is understand that this thing right here, this little piece, is some angle theta. So all you do is you draw it. Now if the range is quadrants 1 and 2, it's positive 3/5, which means your triangle should be right there. 3, 5, 4. There's your theta. So now it's saying, well, what is cosine of theta? look at the triangle, it's 3/5. Now you're probably wondering, why didn't we just cross it out? And that is true for this particular problem, you could, but you have to understand the theory, because if you look at letter C, look at what happens here. If we do the exact same method, let's make that 3/2. This is 3 and this is 2. If you were to cross out and write 1.5, you definitely get it wrong. You have to realize that this triangle is impossible. It's impossible because the hypotenuse is too short. It can't be 2 if a leg is 3, which means this one, there is no solution. So that's why you don't just want to cross it out mindlessly. You have to understand exactly what you're doing. Now for the circle problems, I'm going to show you a couple techniques here. The first technique is the easiest. You just evaluate this inside part. So evaluate. You guys should know what that is. That's simply -1. And now it's exactly like the things we were doing earlier. We're going to highlight quadrants 1 and 4. -1's down there. So to get there, that angle, that's -π/2. Done. For tangent, same thing. Evaluate that thing. Tan of 5π/6, that is -√3/3. So now we're going to do tan inverse of that. We highlight quadrants 1 and 4. -√3/3 is right there, which means the answer is -π/6, or -30 degrees. So not too bad, right? We just evaluate the inside and then do what we were doing on page 1. Now it gets a little harder if you get something like this blue box. The limitation on this method I just showed you is what happens if you couldn't just evaluate it. Well, in that problem, in that sense, you have to draw it. So let's highlight 1 and 4. 5π/8, that's going to be in quadrant 2, a little past right there. So we can see we are not in the range by drawing it out that way. But what we can do is use reflection. So for sine, you simply reflect over the y-axis, because that's not going to change the y value. And by reflecting it, we're going to put it within the range. So now we have, if you reflect that, that new angle is going to be 3π/8. And that's because if you think about this full rotation here, this would be 8π/8. So this angle here should be the same as this angle here. They're both 3π/8. Which means I can rewrite this question as this: sine inverse of sine of 3π/8. Now we can cancel it out because we are in the range, and 3π/8 is our answer. So that's going to be more of an advanced question. Okay, so here's a couple more examples. I know this is kind of hard, so we'll do a couple more examples to make sure we're okay. Let's quickly classify these. So this one, we can see the inverse is on the outside. This makes it a circle question. I'll just put a circle. Inverse inside, so triangle. Inverse outside, circle. Inverse inside, triangle. So the triangles we'll do first, those are easy. So again, you could just draw the triangle. I'll draw a triangle quadrant 2, because it's negative. So I'll put -0.41. Cosine of this, that's just -0.4. So basically they cross out. Now this one's kind of tricky because pi, remember, that's just a number. So let's just make that pi and 1. Pi is about 3. So we can see that this thing is impossible. There is no solution here. Now for the circle ones, let's do the easy one first. Let's evaluate part C right there. So if we evaluate this thing, the cosine's even, so negative doesn't matter, cross it out. Cosine of 2π/3, that'd be -1/2. Now we evaluate the inverse of -1/2. Draw your circle. That's right there. And look, you get 2π/3. No problem. Now the last one, this is the more advanced one. So π/12 we have to draw. Hopefully we know that's somewhere in quadrant 1. Notice how we are in the range, which means we're good. Just cancel it out. You get π/12. That's your answer. Okay. Final part. So now we have triangle problems if the functions don't match up. So again, this is no problem. Look at this inside part. That's your angle theta. Tan is quadrants 1 and 4 for the inverse. So it's positive 5/12, which means this has to be in quadrant 1, 5, 12, 13. Here's our theta. Now we want cosine theta. So just do A over H. That's going to be 12 over 13. Done. Now the final one is going to be using algebra. Notice how, again, this is a triangle question. Okay, sorry, triangle here. This is a triangle question, but we have an x. That's okay. Just think of it as x over 1. So here's my triangle. For variables, you can typically just assume they're in quadrant 1 to make it more simple. So x1. Now you got to figure out this side. So if you're good at this, you might be able to do it in your head. Otherwise, just write out what I'm going to write out here. Question mark squared plus x squared equals 1 squared by the Pythagorean theorem. So question mark squared should equal 1 minus x squared. The question mark should be the root of 1 minus x squared. So I'm going to erase that. This should be the root of 1 minus x squared. Now we're going to figure out if this thing was theta, that's a triangle we just drew. So cosine of theta, that's going to be adjacent over hypotenuse. That's just the root of 1 minus x squared over 1, which is the root of 1 minus x squared.